this is the objective that we are going to learn about the metrology lab, its significance in the industries, what is the significance of metrology science in the industries, and what are the various or basic instruments that are present in any of the metrology lab. These are some basic apparatus available in our metrology lab. The first basic equipment is Vernier Caliper. I think you might have seen in your physics class or in some of your science projects in your school level. And then we have a Vernier height gauge. It is a special gauge, similar. It's working on the similar principle of Vernier Caliper, used to measure the height of any object. Then we have a micrometer, or which is called a screw gauge. I think you are also familiar with this equipment. Then we have a tool maker's microscope. It is a special type of microscope which has some measurement capability. It is used to measure small dimensions, small features available on any sophisticated tool or instrument. This is a very important tool for the quality and inspection purpose. Then we have a dial indicator. You are also familiar about the dial indicator. It gives a small deflection in terms of linear measurement. And then we have this sine bar and slip gauges. This sine bar and slip gauges both are used in all together, and they are used to measure the angle of any particular object or any angular dimension. Then we have an optical flat and monochromatic light source. This particular arrangement is used to measure the flatness of any object. Then we have this bevel protector. This protector is similar to your protector which you are using to measure the angle, but here the principle is somewhat different and based on the linear principle. Then we have the angle gauges, another instrument used to measure the angle of any particular object or dimension, any slot available in your particular object. Then we have the optical profile projector. It works on the principle of generation of profile and then measurement of that profile using some scales available on our instrument. Then we have this double disc polishing machine. This is a particular machine which is used to polish and grind your workpiece so that it will become smooth and it will have a highly mirror surface. And that surface you can visualize under this microscope, which is our metallurgical microscope, used to see the microstructure, grain size, velocity, and all the metallography studies for a particular specimen. These are some basic apparatus, and apart from these apparatus, we have some sophisticated instruments which I am not going to discuss here, but you will have the chance to see all those equipments when you enter my lab. What is metrology? It is derived from the Greek word which is called metrologia, and in some references you will find it written as metron logos. It is a science of the measurement, and it has different domains of measurement, and different quantities can be measured with the help of this science, like measurement of length, measurement of any time, etc. Depending upon the field of application, it is divided into different types of metrology. It may be industrial metrology, it can be a medical metrology, etc. You name the field and you will find its application, because this measurement starts from your daily life routine. You take an example. If you go to a market, if you want to purchase any shirt or pant, you have a measurement in your mind. You see the measurement that it is a small size, medium size, or it's a large size, or it is an extra large size cloth. Depending upon the size and measurement which suits to your particular shape and body size, you purchase that particular cloth. Engineering metrology or industrial metrology, we mainly focus about measurement of length and angles. Length, angles, temperature, and other quantities are expressed in linear or angular terms. Okay, so temperature you can measure in degrees and Fahrenheit, so that is also measurement and also comes under the metrology. And what is the significance of metrology? So I think he might have given you that if you want to produce any product, and if it is of a particular shape and size, it is very difficult to manufacture your product as per the design, size and shape. Because what is the problem with manufacturing? You will find there are lots of error, and these errors, they don't let you to reach your actual or true size. So the errors can come into picture due to the error in the machine. It can be error in the tool, or it can be error in the operator skill itself. Due to this error, there is a problem in manufacturing the product into the actual size. For that purpose, what is defined? You define the limits. You define the limits. There is an upper limit, there is a upper limit and the lower limit, and in this particular range your size is acceptable. I gave you an example that if you want to wear a spectacle, and if you want to suppose if you want to wear a shirt, then you see the size range. Okay, nowadays if you see there, then online platform has given you to purchase the spectacle, that like there is a website called lenscard.com. If you want to buy a spectacle, then it automatically measures the size of your face, and it gives in the range that this particular range is suited for your face width. Artificial intelligence has created that platform and had given you the opportunity to measure things without any physical equipment. So that face recognition and image analysis is done, and then it gives you a size range for your particular face width, the size of your spectacle. You select that particular size and then order that thing for you. Okay, so the measurement is very important task for an engineer, because this is directly related to the quality of your product. You measure the quality with the measurement of different attributes and aspects of your product, like shape, size, physical appearance. Suppose if there is a strength application, then you measure the strength, and all the things related to the measurement, it comes into the metrology. So the metrology has a very good significance in your day-to-day life in the industry. It gives you the direction to think that how you can minimize the defects and how you save a lot of money in your wastage. This is very branch of science. In big industry, you will find a particular section called quality and inspection, where you will find all these equipments which I have already mentioned in my previous slide. You have to understand the working and learning of all these equipment for your future purpose. Because if you don't know how to operate all those machines, you will not be able to guide your operator. In many situations, whenever you reach any industry, they try to take your exam. Even a small worker which is at very lower level, he will try to ask something from you, sir, that how much you know and how much you have gained from your engineering. You have to learn the working as per your interest and for your future use. In metrology, we have a very important term called accuracy. I think he has already discussed about the accuracy. The accuracy is the degree of agreement of measured dimension with its true magnitude. How close you are to the true value gives accuracy. It is calculated in terms of the error, the difference between the true value and your observed value. Another important term is precision. It is the degree of repetitiveness of a measuring process. It is the repeatability of the measuring process. If an instrument is not precise, so it will give you different results for same dimensions for repeated readings. Okay, so both these terms, accuracy and precision, very important for measurement using a instrument. First, what is the first diagram? What it shows you? It gives you an idea that this is a circle and it shows the domain or acceptable range. Okay, acceptable range of your measurement, and the center point is true value. How, if you see that what is the location of your measurement is a closed cluster outside the desirable range, then your instrument is precise but not accurate. Okay, and in the second diagram, we shows that in a particular domain, the scattering is very close or near to the true value. But if this scattering is not in cluster, it is not at the same point. So that means your instrument is accurate but not precise. Third shows you that all the measurements are very close to your true value and their position is very closely spaced. That means it is precise and accurate. And fourth one is it is neither precise and nor accurate. So this is the difference between the precision and your accuracy. Then I have already told you that it's very important to know the error in your measurement, and it also gives you a direct idea about the quality of your product. That if all the errors for all the geometrical dimensions, for all the measurement, if this error is very less, for any manufacturing purpose, you define the level of the error, that it is 2%, it is 1%, it is 5%. So that error for different physical attributes and different dimensions, this error must be defined. It is a difference between the indicated value and the true value of your quantity which is measured. And this can also be calculated in terms of the percentage error, which is the error divided by the true value. So I have already explained that accuracy of an instrument can be assessed in terms of the error. These are some of the equipments that are available in a metrology lab. This one is your combination set, which has the slip gauges. These are basically the rectangular blocks which are very accurate in dimension, and all the blocks have imprinted dimension, that what is the length of these slip gauges, and they have two surfaces. Both are perfectly lapped and polished and have very high degree of the flatness. This is an equipment, you all know that this is a Vernier Caliper, this is a Vernier depth gauge, this is our micrometer. It's a semi-digital micrometer, and this is fully digital micrometer. This one is your gear to thickness caliper. So we'll be studying all these equipments in our upcoming classes or experimental sessions. This is our equipment which is called the surface roughness tester. It is of very good quality and we purchase it from Carl Zeiss. Carl Zeiss is a very reputed brand in terms of surface metrology or the measurement of surface roughness. This is a granite table, which is your called flat table. It has a very high degree of flatness. You can easily identify the measurement in the flatness. This is our semi-micro weighing balance, and it is also very accurate. We had purchased it from Shimadzu. It's also a very reputed brand, and it has a very good accuracy of plus minus 0.01 milligram. You can measure weight up to 5 decimal places in grams. Okay. And this figure is of your monochromatic light source. You see that there is an orange color light which is falling on these circular blocks made of quartz material. These are called optical flats, and they are the quickest, you can say, it gives you the quickest method to measure the flatness of any object. Whenever you go to any industry and you find any quality inspection shop, you will definitely find this particular cabinet, and some of the objects, these optical flats are placed over on these objects, and it will give you direct reading that how much it is flatness. Whenever you look onto these optical flats, and if these are placed on some object, then you will find, you can see fringes, some fringes, optical fringes, some vertical lines over it, and which gives you a direct measurement about the flatness of any object. We will discuss all the details in its particular experiment. This is a digital tool microscope. This is our measuring head, which has a very high resolution digital camera. It has a small micro probe which is used to measure the dimension in the 3D. So it works like a 3D dimension measurement machine, a small gear which is placed below the camera, and then its image is acquired onto the surface. You see there, this is a gear profile. It's an involute this gear profile. There is a special software built inside this computer. You can do all the processing. You can grab the image. You can do image analysis and do a measurement of any particular feature. Just like in this case, you can easily measure the width at the top land and angle between this gear teeth. All these dimension you can easily measure. Then we have this optical profile projector, and it's a very simplest type of projector, and it is also present in most of the metrology lab or inspection lab. What happens here, this is a table, and below it there is a illuminating light source, and it has a glass table. You place your object over it. At the top there is a, you can say, there is a lens which acquires the image, and under this cabinet there is a series of the mirror which converts the inverted image, and then you can see the image, upright image, onto this particular screen. It works on the principle of projection. What is the projection? Here on this table, when the light falls from the bottom side, there is a shadow which is developed inside this lens, and then with the help of this series of mirror, you will see a magnified image on this screen, and it has also a scale, and then you can also measure it with the help of your journal scale. This lens has a different type of magnification, and it has a removable lens, so you can change the different lenses, and it has a magnification mentioned on all these lenses. Whatever the geometry or dimension you are measuring, it will show the magnified image. With the help of a simple scale, you can measure the dimension and then divide it to get the actual dimension of a particular physical attribute. We have this particular instrument or a device called a sine bar, and you see there that this is made up of a very highly wear resistant high carbon high chromium stainless steel, and it has two rollers, cylindrical rollers, which are attached onto this surface, and then one surface is rested on the base and other surface is rested on this rectangular block, which is your slip gauge. This gauge I was talking about, and it has this shiny surface. This surface and the bottom surface both are parallel to each other, and all these surfaces are highly flat and has a high degree of smoothness. You measure, you get the distance between these rollers. The center distance between the center point of this roller is known to you, and this height is also known to you. All these slip gauges are used in combination to achieve a specific height. With the help of this height and this particular h, if you put all these value in the sine formula, and then from that sine inverse you can get the angle. This particular angle you can measure what is the angle. And then this is your vernier height gauge. It is a similar type of instrument which is very similar to the instrument. You can move this head up and down. You place your object on the base table using the stylus. You place this over the maximum peak of that particular object. This is your manual type of vernier height gauge, while this is your digital type of height gauge, which gives you direct measurement of the reading. Then we have this another apparatus which is called a double disc polishing machine. It has two rotating tables, and currently this is covered with some two flaps. Beneath it there is a rotating table, and there is a arrangement, or you can say a fixture to affix the sandpapers, emery papers, which you all know that is used to smoothen and grind the surface. Both these tables rotate at predefined velocity using these knobs. We have a facility to fix the timer, and we have a facility to lock the RPM, and then you place your workpiece over this rotating table, and with the continuous abrasion and sliding motion of the rotating table, it smoothens and it grinds the workpiece. So that after grinding and smoothing the workpiece, polishing the workpiece, you place the workpiece on this particular table. We have this very sophisticated metallurgical microscope. This is called an inverted metallurgical microscope, and it is different from what you have seen in your physics or chemistry lab, which was called the upright microscope. In upright microscope, your measuring lens is at the top of your workpiece, while in this case your measuring lens, you see there, this is a turret which has different lenses of different magnification, and from the bottom it is grabbing the image. This is our digital camera which is connected with our computer, and then we can analyze its image and microstructure under the microscope, and it is transferred into the image analysis software. Okay, and many institute have this manual type of metallurgical microscope, but you see here we have a special arrangement at the back which is used to make it fully automatic. This is a fully automatic metallurgical microscope in our lab that I purchased 2 years back. It has a very good image quality. You can use it for your research and for education purpose. So these are some of the equipments which are available in my lab. Many equipments are there to measure the dimension of a screw thread, diameter and their pitch, and all those sophisticated dimension and physical attributes can be easily measured in this particular lab. This was a very brief introduction to our metrology lab. So if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.